of innovation. And now we are switching a little bit here from innovation to business. So we have our next speaker, Anna Lee, and she is one of our MD PhD students at University of Pittsburgh and Carnegie Mellon University, doing her PhDs in computational biology. As a second year medical student, in the middle of pandemic, Anna started a project to develop an affordable electronic. She became the founder and CEO of Korean Health. They have raised $2 million to that, and including a $1 million global health prize. She is also a first place winner of AHA American Heart Association Business Accelerator Award. All right, welcome, Anna Lee.
Can I switch out my computer? Yeah, we have an HDMI cord here. So just... Sorry, thanks. Okay. So we're kind of running a little. Yeah. Okay. That's good. Okay. Okay. All right. Well, thank you very much for having me here. I'm really excited to be here and really honored that I get a chance to talk to you all. I'm Anna, as mentioned, and I'm the CEO and co-founder of Korean Health. And today I am here to kind of share my story as I was sitting in cardiology class taught by Dr. Jennifer Lee as a second-year med student, and how that ended up turning into a company completely by accident. I have no business background, and it's been a crazy journey, but I think it does go to show that if you are from a clinical background and you don't have any business background, if I can do it, you can certainly do it. So yeah, without further ado, just a little bit of background on who I am as a person. Was born and raised in Chapel Hill, North Carolina. My parents immigrated from China. For those who've heard of the one-child policy, I was an oops second baby, so they came over here to have me. And then I went to Duke University and have a joint biology and engineering background, graduated in 2018. And just to make some people feel old. And then I've actually been doing cystic fibrosis research since I was in high school. My high school best friend has cystic fibrosis, and she really inspired me to go into research because there were no medical treatments available for her at the time. But it's been a minute, and a lot of personal growth happens in 10 years. So my path has been very winding. I know people who wanted to be doctors, and I think it took me a couple different career paths to try that out for myself. So when I was a kid, I loved puppies, so I really wanted to be a veterinarian, but quickly realized that I probably didn't have a strong enough heart for that happens in that field, and that's hard to deal with. And then I met my best friend through marching band. Everyone else is a band nerd or plays clarinet. And she inspired me to go into research as I realized that I wanted to push the boundaries of what was possible and not just kind of like walk the same path that's always been walked. And as I was doing some research, I did my undergraduate thesis at UNC Chapel Hill with Dr. Scott Rendell, and this is a picture of me playing a game called League of Legends. I don't know if you guys have heard of it. It's a video game that's like a multiplayer strategy game, and something that's really important in any war or battle style games is strategy and in knowing the landscape. So it's really important to know your own abilities and what the enemy's abilities are, but it's also important to know where you're going. And I think as I continued in my research, I started to feel like I didn't understand the battlefield, which was the human body in this case. And so then I graduated from college, went to see, and I was like, maybe medicine. But because I'm very indecisive, I ended up applying to both. So I'm in the MD PhD program. And I think having had a very liberal, possibly naive perspective of life as a recent college grad, I thought the solution to a lot of the issues I was seeing in clinic was going to be free and open source solutions made by student volunteers. But at a certain point, you keep trying that, and then you realize the solutions just die after your grant funding goes away or when the student graduates. And I finally kind of let myself be talked into social entrepreneurship. And that is the journey I'm going to tell you about today. But I think all these specific things aside, oh yeah, and I also might go into policy at some point because I'm very concerned about the world. But anyway, But I think all of these individual decision points aside, there's a pattern that you can really see happening that continues to show up in my life, which is that I have some observation about something that I'm good at or something that I really love doing. I try it out, like when I tried shadowing in the veterinary clinic, and then it either goes well or doesn't go well, and I pivot based on that. And that is the kind of model that I continue to live my life by. I fail a lot, I try a lot of things, and then I continue adjusting. But it's ended up kind of working out okay. Okay, so we're going to get subscribed go everywhere in a minute, but if you have your computer or your phone handy, I would love to see some presentation. I think one of my goals today is also for you to realize what the interests are of the others in this room, because none of this I could have done on my own. But, something to have a common interest discussion on. So there's a QR code, and there's also a website. If you go to polev.com/Emily976, would love to hear what your childhood dream job was, and how many people here always knew they were going to be a cardiologist, or if it was something else. And hopefully this activates and works. Okay. Yeah. Sorry, questions? No. Okay. Never mind. So, all right, I'll give a minute for responses to come in. Oh, it is? Okay, that is the next one. I guess we could start there. Oh, okay. Let's see if I can. Yeah, I am not sure why why it's not. Oh my gosh. Okay. If I go to the screen, can you see the first question? Let me hold on. Give me 1 second. I will troubleshoot this. I guess you can see right there. Hmm. Okay, if this doesn't work, we can also just do like raise of hands. But I think it's nice when you can see everyone's responses. Yeah. Okay. Is it still skipping one ahead? I think if we can get this to work, it'll be really cool. But I did come prepared with a potential technical difficulty. Okay, so I'm gonna try doing it this way. What was your child? That worked? Okay, great. Thank you for your feedback. Um, with this. Aha! Yay! Okay, thank you very much for participating. Oh, another potential veterinarian in the house. Exciting. I almost brought my dog to this event. Okay, yeah, thanks everyone for participating. So I hope you can kind of appreciate that there's actually a lot of diversity in interests in medicine, and everyone I'm sure has their own winding path to how we got here. Astronaut is surprisingly large. I'm curious if anyone's gonna make a career path switch. Okay, thank you for playing, and I'm gonna go to the next question, which was, what did you go into medicine for? And I think this is an important question to me because I've kind of always gone into medicine for the same thing. I've always wanted to make an impact. But as I've grown up and learned more about myself and about the world, I think my hypothesis on how I make that impact has continued to change and evolve, and I'm sure it will continue to do so. So is it is it working? What did you find about this? Whoa, these events. Great. I think my slides might be frozen. Panic. Okay, that's fine. I will relaunch. Struggling. Sorry. Okay. Usually for the med school, I'm like the tech support troubleshooting it, and now now I see it's not so easy when you're the one in the hot seat. Okay. All right. How do I get it to see responses? Ah, yes. Okay. Excellent. Oh, there's only one response. Okay. So someone went into medicine to be a pilot, which is, oh yeah, okay. Um, okay, that's okay. We can just move on. I don't want to take up too much time on this. Um, I think that the general goal was to see like what the room thought about like what the primary issues were in medicine, why you went into medicine, and try to build some common ground there. But I'm gonna go ahead and pause this so I can continue my presentation. Ah, cancel. Hold on. Okay, 1 second. I'm gonna restart PowerPoint because I think it maybe can't handle how great the responses were. Okay, let's skip ahead here. Yeah, thank you for bearing with me. I need to also restart my live stream. Okay. Okay. Okay, so let's pretend that worked as smoothly as I would have liked it to work and move on. Okay, so when I was starting out as a medical student and having also been a lifetime patient advocate for my parents that don't speak English and a patient myself, I quickly noticed that there's a lot of barriers to accessing healthcare in the US. So cost being one of them, there's also time, transportation, and what I'll generally call cultural competency or compatibilities. So my parents came from China and they have a very hard time trusting Western medicine, which is very ironic. But there's my point is that there's a lot of barriers. So healthcare is not necessarily easy for people to access. And as someone who started medical school in 2020, I think I saw a lot of these really in center during the pandemic as people were afraid to come into the clinic because they didn't want to get sick or because they were uh, too far away or for any other reason. And so over 80% of people in the US face at least one barrier to accessing healthcare, and this results in a lot of issues. So as I'm sure this audience needs an introduction, congestive heart failure remains the #1 cause of hospitalizations in the Medicare population with a lifetime risk of 1 in 4 people. And this costs a lot of money, and about 80% of those, or here, come from inpatient hospitalizations and ER visits. So the goal of care is really to make sure people stay out of the hospital. And this is another diagram that I got showing that as you have one exacerbation, your quality of life kind of hits a lower ceiling and then it continues going down. So the goal is to keep people at a higher quality of life. I can see Stephen Chan, my small group leader, looking at me to make sure I have all the facts right. Oh, whoops. Sorry, I did not even realize that was happening. Stop. These were stop. Can I mirror this? Yeah, let me see if I can mirror the screen. I don't want it to have two displays. There's no comments. Mirror, yes, display settings. Okay, you know what? I'm just gonna roll with it. Hello. Okay, I just
swap displays.
here.
There you go.
Oh, okay. Thank you. I appreciate that. Okay, let's see. Okay, so the data shows that about 10% of hospitalizations could actually be prevented through outpatient care and having better continuity of care. And congestive heart failure and asthma are the leading causes of hospitalizations in adults and pediatrics, respectively. So I was hanging out in the ER trying to learn because I want to go into emergency medicine. And what I noticed is there's kind of like two patients that are there at the wrong time, off of their own. The first is my friend, Alan, who gets like a little paper cut on his finger and is like, it could be microsoft. And then he's like, it's better safe than sorry. And so he just goes into the hospital, even though he really doesn't need to. The second group is people like my dad who will be in a lot of pain and then say like, back in China, we just toughed it out. And there's nothing I can say to actually get him to go for a checkup until he actually has some sort of event which he finally goes to the hospital. And so I think these people are operating off the same model that I am, where they have an observation, but then in the absence of information, there's an unknown and then an assumption that is made, which ultimately to either them going to the hospital too early or too late. Okay, so I'm gonna just have this be an open question, so because I don't want to mess up the formatting again. So could I get some hands for what you think it would take to eliminate 100% of preventable congestive heart failure patients? Anyone? It's an intractable problem. That's okay. I think so too. Okay. Well, oh, sorry. Yeah, home care. I think that's one that's very close to my heart because it's so hard to get my dad to go to the doctor. Um, Anyone else have thoughts? Maybe congestive heart failure isn't like a focus here. I know there's a lot of different types of heart disease. Okay, I'm gonna move on. But I think a big one that I've been thinking about is actually using machine learning in healthcare. And I'm doing my PhD at Carnegie Mellon in computational biology, currently taking one of their hardest machine learning classes. So if I seem a little loopy, it's because we had the midterm yesterday. My brain is still coming back online. But there's a lot of excitement around machine learning and AI in healthcare today. And I do want to point out that from a very basic statistical level, the goal, of course, is to get high accuracy and clinical utility. And for that, you need low variability in your data and a large sample size. And I'm personally a little concerned that a lot of the algorithms I see being deployed are relying on a large sample size without realizing that the data they train on is sometimes very messy. And so what does low variability for data actually look like? It means controlling for variables. So, having the same protocol, recording the same types of data, and then forcing functions to make sure that human error is as low as possible. For large sample size, what would that look like in a practical sense? Well, that means removing bottlenecks, such as mentioned, home health care and being able to reach people from home, having an affordable price point. I think we spend way too much money in healthcare today, and a lot of that comes from inefficiencies, and also ease of use and patient engagement and trust. As we saw during the pandemic, we can have a great vaccine that's very effective, but if you can't communicate that to your patients, in many ways, we're still failing them. And so you've probably heard the term getting the right care to the right patient at the right time. And so that's something I've been thinking about a lot. And so my understanding from cardiology class, and forgive me if this is a little naive because I am still learning, but my understanding is that pulmonary wedge pressure increases, and what happens is that there's some precipitating event where it might get worse, and then a hospitalization. But there's a lot that goes on in between. The filling pressure will increase. You get some autonomic adaptation. As we learn in med school with the stethoscope-based exam, we can listen for an S3, which is the reverberation of the fluid inside the heart when there's too much fluid. You get pulmonary edema, weight changes, and eventually you get hospitalized. And so the goal here is to capture something about some data about the body early enough that you can intervene, but not so late that it's too late to intervene, if that makes sense. And so I've kind of roughly mapped out where the symptoms might occur and then when you might be able to intervene before those symptoms show up. And so when I was about 3 years ago, when I was taking Jennifer Lee's cardiology class, we were learning how to use a stethoscope. And like any good engineer, I started thinking about what the component pieces for it were, which was you need to hold the stethoscope, you need to listen for it, and you need to know where to place it. And I started to think about whether we could use technology to solve these barriers so people can actually get these screenings. Okay, so I'm going to just pass over this in the interest of time. But what we ended up creating is an electronic stethoscope, and after this, I'll be at table 3 if you want to try it out. But you'll notice it has a blinking light because stethoscopes are best used on bare skin for best sound quality, and the light allows it to shine through a regular t-shirt so people can still maintain privacy. Additionally, a computer vision algorithm inspired by Snapchat, I don't know how many people here use that, uses augmented reality to project a red dot on your phone or your computer over like the aortic valve region, the pulmonic valve region, etc., and only records once in the right place. And this is what we consider a forcing function in engineering, so that if it's in the wrong place, it won't collect the data at all. So this did not start. It did not start as a fully conceived idea. I think for a lot of people interested in innovation, you just got to start somewhere, and you have to be open to the idea that your first idea is not going to be the one that takes off. And so I actually started at the Pitt Challenge Healthcare Hackathon, which I believe is open to all fellows and residents as well. They have some small prizes, like we got first place, $2,000. a little something to this student who's on a stipend. And we started going for bigger and bigger competitions. And I do want to point out that these are all competitions that are open to everyone here. So if you're interested in innovation and you just want to try it out and see what happens, these are very low-hanging fruit and very approachable competitions where you get a lot of mentorship and help along the way. But at a certain point, we started to become a real company. This is when I was having conversations with my mentors about whether we can make it free and open source. And I kept hearing that if we put it on GitHub, either it dies in the graveyard of GitHub projects, or another company will take it and mark up the price and maybe corrupt the dream that we had for like maximizing accessibility. So this is a artistic rendition of how I felt at the time. This was about 2 years ago. I kind of felt like I was at the edge of a cliff, and I could either decide whether to jump off and start this venture, as in taking other people's investments. Like once you take other people's time and money, it feels a lot more stressful than if it's just my own time. And I had to really consider that it might lengthen my graduation timeline. My mom wasn't super happy about it. She continues to ask if I'll graduate and get married at some point. And I'm like, Mom, I'm busy doing things to suit you. But at a certain point, I felt like I had no choice but to jump off the cliff because I knew what the impact could be, and I felt like I had an ethical responsibility to try and make it work. So I jumped off the cliff. It's a little scary. I'm not gonna lie. It's kind of part of the thrill of starting a company. You don't really know what's going to happen. And I'm going to be very honest with you, it was very scary at first. I have a co-founder, Ikshaya, and to give you an idea of what's going through our heads, this is a representative snapshot of some of our texts that we exchanged along this early time period. You will see that one word comes up over and over again, which is panic. But it was nice that we at least had each other, so we were going through it together. And we're still falling, but eventually what happens is if you have faith in what you're doing and you're working on something meaningful, I think people start to see that. And we have been so fortunate to have so many enablers and so much help in the community that eventually form a parachute. Some of those are, or many of those are local Pittsburgh folks. So this is Ben, who runs Encompass Remote. I don't know if you guys have heard of him. He runs a home healthcare company for congestive heart failure. Paula, who runs the Richard King Mellon Foundation Social Impact Fund, and then some folks from Lipex and Brian Beyer, who ended up coming in and joining the team as an advisor and also as the leader of the kind of hardware engineering team. And I've just gotten a lot of great support. I volunteer at Penn Hill's Charter School for Entrepreneurship, and the kids have been so excited to use this and give me some of their feedback. We have community members who are testing out the device, and this is a group called Chloe Capital, which is a group of entrepreneurs lifting up each other. And it starts to feel a little less lonely. And so just a shout out to all the groups that have helped us. But then, you start to garner more attention. And what we ended up doing is as we started getting bigger and bigger, I kept that they wanted to be able to contribute and help. And we did something pretty unconventional for a medical device company, which is we did a crowdfunding raise. I've gotten some offers from venture capital firms at that time, but for those who aren't familiar, the primary goal of these firms is really profit and maximizing those profit margins as you can. And I really wanted to reach regular people because I could see that people were feeling really alienated and isolated from the healthcare system. And so I wanted to include them in this journey. And we ended up doing a crowdfunding raise where it was very successful unexpectedly. We raised over $150,000 from almost 100 people in the community. And then I just made a little video where you can see some of the comments from people. We had doctors reaching out in Squirrel Hill who were like, hey, I want this device beta tested or something. And it was really lovely that we were building not just a company, but really a community around healthcare access. So it's really inspiring to me. And a couple bigger prizes from $10,000 prizes to $75,000 prizes. We got first place at the Upprize Social Innovation event in and then we also were the first place grant from the American Heart Association for the Business Accelerator, and it's been. Oh, I also got to meet Vivek Murthy, who is Surgeon General, so that was really cool. So it's been very humbling and very exciting to see people join. And what ended up happening is, you're still falling, and at a certain point, you're going to hit the ground. And what happens? Some companies implode, and some companies do other things. And for us, we ended up forming a trampoline and bouncing. We bounced so hard that we bounced across the pond to the other side and got accepted into something called the Whole Prize Business Accelerator. So those who don't know, the Whole Prize is probably the biggest social entrepreneurship competition in the world. It's open to any students. Live in something called the Asher's House for a whole month as we work with people all around the world and the United Nations, refining your vision for what you want your company to do. Although in reality, it looks more like just playing cards with student members all over the world. And out of the 10,000 teams that applied, I'm very humbled to say that we got first place there. It was a really surreal experience in London. I think, especially for me, growing up as like, the daughter of Asian immigrants, I was kind of taught growing up that I should be more quiet and obedient and listen more than I talk. It was such a formative moment for me when I spoke and people were actually like excited to listen, as hopefully it's currently happening. So yeah, and then I did have to take a month off of school for that, and so I felt like I was coming back after going to this accelerator. And before I had left, my PI was a little concerned, like, do a company and grad school at the same time. And then my program director was like, you better pass these classes. And then when I came back, I was like, please, I'm bringing you prestige. And they were like, actually, this is okay. Yeah. So I did feel like I had to kind of work it a little bit. So I was able to stay in the program. It is hard to balance everything. For those who don't recognize this, this is from my favorite movie, Mulan. So anyway, what's next? We've done a patent FDA clearance for late 2025, and currently are working on a clinical pilot. If anyone sees a use case on potentially using this to monitor heart failure and postpartum women, if you taking to the clinic, might be more interested in something that engages them in their own care. This is the area that I really need help in. I think my strength is kind of like the innovation side and the engineering and patient advocacy, but obviously I'm still training. I'm not a real doctor yet, so please help me. And then building a home screening kit and animal-based diagnostics. So I brought both of these prototypes today, but just to give you an idea, this is what the original prototype looked like. It was actually printed in the makerspace in Benedum Hall, which is right next to UPMC Presby. So one of the things I've been trying to sprinkle into this talk is a ton of resources for innovation. They're all free, they're all available to students and faculty. And if you're ever interested, it's much easier than you think to get started. There is a horde of enthusiastic undergrads running the makerspace who would love to talk to you about your ideas and help you prototype, myself included. And now that we've kind of got some more funding, we polished it into more of a commercializable product, more ergonomic, meant to look very friendly and patient focused. I'm sorry, this is the only picture I could find of myself with a patent, but we got a patent granted, which was very exciting. And just to give you an idea of what that looks like, so you can't patent a stethoscope, right? But what you can do is you can patent the intersection of a technique and a way to oversee that technique. So, for example, in our computer vision algorithm, we use something called POSNet, which basically uses all these points on the body, your eyes, your ears, your nose, etc., to localize where your heart valve positions are, and then we have a percentage over from each of those posts that we use to calculate these computer vision algorithms. So that was patentable. I thought I'd also toss in this one because I think it looks ridiculous. But apparently it gets the message across, and so the USPTO is like, sounds good. So this is all just to say you don't need to be a professional artist or anything. Like you can use MS Paint as long as you get the message across. It's fine. And also surprisingly, we were able to patent a machine learning algorithm. I will say something that struck me is the things that we can patent today are not the same as the ones we could patent 10 years ago or the ones we could patent in 10 years. And so there is something to be said for getting a patent earlier. This was something I wasn't sure if I wanted to patent, but our advisor was like, they're currently figuring out how to do, so you will just get it in there. And I think at my core, I really do have a strong belief that algorithms and machine learning should be something that's accessible to everyone. And so, again, maybe a little idealistically or naively, I brought up that I didn't want to patent for the sake of exclusivity. I wanted to patent for the sake of inclusivity. And so, if you have that mentality too, something to consider is you don't need to enforce your patents. Something just means that you have control over whether someone else enforces it. And capitalism can be great because It's kind of a free for all, but also you can use it for good. You can things and make them openly available. There's also something called patent blocks. You want to make sure everyone can benefit from something. So something to consider since it's something I've been thinking about a lot. And then just to wrap up, our ultimate goal through Coriat is to build a complete complex kit with inclusive and interpretable ML machine learning tools that puts healthcare in the palm. And regardless of the distance, and this is kind of the mission, even when it's hard and confusing and my mom's yelling at me. And so just to finish up here, I think if you want to work in innovation, kind of the three ingredients are going to be creativity, which I would also say takes the form of diversity because we have such a diverse team and because I think I've had many different life experiences that have led me here. The grit, things are going to go wrong, things are going to be scary, and being able to continue to solve those problems is something that I think takes a lot of courage. Okay, and that said, if anyone's interested in learning more about this, I have a couple of my favorite book recommendations. My all-time favorite book is actually Kill a Mockingbird. Most of you probably don't remember this from like your required reading in middle school, but the premise is about a white lawyer in the Jim Crow era who defends a black man who's been wrongly accused of rape. And even though he knows he'll never win this case because of the culture at the time, he still tries because he feels it's the right thing to do. And I think a lot of people say I'm very optimistic, but I really not. But I feel like I have to try anyway if we're not going to succeed. Yeah, I'm happy to talk about the other books, but these are just some that have like really shaped my thinking. And yeah, I would love to hear from you. Feel free to find me at table 3 or email me later. So thank you very much for your time and attention. I'm sorry for the technical issues, and I hope this was kind of interesting. Yes.
First, this is a great. Congratulations! This is a great presentation. Congratulations on Corian, and you should be proud, and we are proud of you. A question about how did you quickly hone down on stethoscope? I know Jennifer Lee is exposure,
Yeah.
but as you're embarking on this journey, did you think about maybe electrical signal? Did you think about ultrasound signal, or you how that happened?
Yeah, great questions. Some of it definitely was by luck. I was just sitting in class like, this could be a fun project. And I did not plan for it to become a whole thing. I think, let's see, why did I pick the stethoscope? I think it seemed like the biggest unmet need that I was witnessing. So first off, it's kind of like the symbol of medicine. So it's very approachable to a lot of people, as opposed to like echocardiograms you maybe need to explain. I am very aware that typically in well-resourced areas, we now order echoes for most things. But something like stage of heart disease occurs, or congestive heart failure occurs in areas where they don't readily have access to echocardiograms. It's sometimes hard to get your head around that because we live in Pittsburgh, and of course, just but I think my personal passion is really looking at those who have been historically underserved. And then as far as electrical signals go, there are electrocardiograms. There's one called cardia. It's spelled with a K, and so it seemed like that was more of a problem. So I just didn't see any other electronic stethoscopes in the field that were really meant for patient use and had the guided interface that could enable reliable use by patients. And I think just that combined with my time kind of volunteering in the Presby ER and seeing people with congestive heart failure come in for things that could have been prevented and hearing attendings be like, man, telemedicine's great, but we can't do a physical exam. I'm like, can we? So that's kind of how that started, and it just kept snowballing. But originally, I actually did want to do something related to machine learning. I was hoping to make it my PhD project because I am hoping to graduate still. But I kept seeing all these machine learning algorithms, and I couldn't find a good training set of data. There's definitely sets out there on GitHub that are openly available, and there's studies that have been done. But like I said, if you really want something to scale and reach high accuracy, you need to have a really large data set made of consistently collected data. So that kind of turned us to pivot toward creating that foundational data set for learning that is inclusive and affordable and easy. Steven.
Say that a lot of courage to get up and do the things that you can. is very difficult and courageous of you to be presenting to a bunch of cardiologists on this particular subject. So we really appreciate that.
Thank you.
I have a question about sort of like what you see your outcomes are going to be. So like in terms of trying to get this to underprivileged, underserved populations, one, do you have a plan in terms of communicating the data that is coming out of their use to what they're seeing? Like, so is this going to be information they care about, that they want to see, or is this going to be information that is going to be transmitted to their physicians, and are the physicians going to then do that to make use of that? And if that's the case, is there going to be a clinical trial of outcome?
Yeah, great questions. It's something we've thought about a lot. I will say this is first and foremost built for patients, but ideally we want it to be approachable to both patients and physicians. A lot of the early feedback that I got when I was talking with cardiologists was that it can be really helpful to see trends over time, as opposed to just like this one thing to just give someone like 100 recordings. Be like, have fun with these. But I would love to use some analytical techniques to say like, hey, your S3 has gotten like 20% more prominent over the last week, and this might lead to a like 40% chance of hospitalization in the next 10 days. You know, just putting all this data down is something that's easily visible. I'm sure there's some mixed feelings in the room about AI algorithms. I'm really a believer that we let computers do what computers are really good at, and that frees up us to do what we're good at, which is like actually being human and talking to patients as opposed to just like crunching data all the time. And so, yeah, my hope is to kind of show the data in a way that you can see trends over time and hopefully use that to predict whether someone will be hospitalized. Ultimately, the goal is to keep people out of the ER. I've been in the ER once as a patient, and it was kind of scary. So I joke that I want to be an emergency medicine doctor one day, but also kind of make myself obsolete if I don't have to be there for someone. Yeah.
It's wonderful what you've done. And the one thing I encourage you, and I think this probably going to what Samir was saying, is that there may be an acoustic signal that you're able to detect goes beyond what we usually listen to.
Yeah.
That's not an S3. It's not a signal that somehow correlates to outcomes, which is what you're looking at.
Yeah, 100%.
And if you could, hone that through machine learning to a risk to the patient, that would potentially, hey, call your doctor, something's going on, or you're in trouble, or whatever it is. But it may go beyond what we are listening for traditionally in our scope. So it may be much more than that. So I think it's wonderful what you've done. I know you've got a journey left ahead of you, but I do think it's got great potential. What you've done, and think beyond what we usually listen for. Think beyond S3. This is what I would encourage you to do.
Yeah, thank you. I think there's a whole lot of data out there that we don't even have access to because we haven't been able to reliably collect this data from home for patients with a high sensitivity stethoscope. I will say part of my formative thinking around this came from my time rotating in Conrad Tucker's lab. You might have peripherally heard about him. He's one of the ML researchers at CMU. Oh, sorry, should I stop talking? Okay. But their lab came up with an algorithm that can detect heartbeat through a video just face. The actual algorithm is actually very simple. Just like runs your face and then takes a square digitally out of your cheek and then measures the average pixel change color over time. And that's sensitive enough to detect someone's heart rate, but it's not like I can look at any of you and detect that. So I really think there's things that computers are much better at, and I don't think it detracts at all from like what we need human doctors for. I think it can actually help us do our jobs better. But yeah, we're probably going to get FDA clearance at the end of this year, and I have functional prototypes here that you're welcome to play with, listen to the sound quality. But yeah, I'm really curious to see what data we see because most of the data we have now is from data in the clinic. And as I'm sure you've all seen, there are times when a patient comes in, they're like, yeah, I had some chest pain, but I couldn't get an appointment till now. And we're like, how are you feeling today? And they're like, I'm fine. And we don't see anything. And there are many conditions that kind of don't have a linear path toward progression. And of course, there's things like the Valsalva maneuver that we can do that can kind of artificially induce these things. But I think if we can collect data at the source repeatedly over and longitudinally for each patient, so we can compare their own baseline, I'm really curious to see what we find. Yeah.
And it's great to see how far you've come. I remember, having you on like the 4 years ago. This was a dream back then, and it's getting close to reality. I think, have you thought about pairing this with cardio MEMS or something? You must talk to Agnes about it.
Yeah, Agnes is nodding. We just talked about that like 2 weeks ago. But yeah, I think the nice thing about this is it's non-invasive, it's easy, it's cheap. It currently costs like $25 to manufacture, which is orders of magnitude cheaper than anything else. And so if we can train that on data collected from these more sensitive gold standard kind of instruments like CardioMEMS or like echocardiograms, we might be able to pull out a signal from this kind of cheaper data. And yeah, it's definitely something we thought about and working on IRB for that. Yeah, I definitely need a lot of help with clinical mentorship. So please feel free to reach out if you are interested in helping with a pilot or talking through ideas. Okay, thank you.
Thank you, Anna, for this wonderful and engaging presentation. So we are now moving to our next phase, which is table topic discussion.
Thank you. Yeah, we had some glitches.
And all other